Hello. Today I'm going to explain some of the developments we've made in our Cisco routing platforms in order to support our customers in their migration to cloud. We've done this because by 2015 it's predicted that more than 60% of enterprises will have migrated branch office services into the cloud. And remember, they're migrating to that cloud at the same time as they're adopting BYOD. So our customers are finding themselves in an environment where users in a branch with multiple devices, some of them now consumer devices like the iPad, over which IT have little or no control, are accessing services and applications off-site in the cloud. And the only thing connecting those branch office users to the cloud is the network. Now, for many years here at Cisco, we've referenced our intelligent network. And what do we mean by this? What does network intelligence mean? Well, in essence, what we mean is that the network knows things and that it can make decisions based on those things that it knows. For example, it knows who the users are, what device they're on, what job role the user has. It knows what cloud application they're accessing. It knows from the Cisco SIO whether a web page a user is accessing is actually safe. And the network also knows all about itself. For example, it knows whether it's congested. So the question for us here at Cisco was, how could we use this intelligence in the network to give our customers the best and the most secure experience when they connect from the branch to the cloud? And the answer is a Cisco Cloud Connected solution. And I'm going to explain what that is. First of all, let me say what the Cisco Cloud Connected solution is not. It's not one new box or appliance. Cloud Connected is a grouping of features and functionality that have been developed on our existing routing platforms, namely the ISR-G2 branch router and the ASR1K. And I'm going to talk you through what those Cloud Connected solution features are. First, we've developed something here called connectors. Now, connectors are essentially software, APIs, which allow third parties who deliver cloud-based applications to integrate their applications with our routers, so that their app can make use of the intelligence in our Cisco network, and so provide even more value to the customer. Think of it a little bit like the way companies build their applications and services and then integrate them with Apple and make use of the intelligence and experience of the iPad and iPhone to deliver what we call apps. So to explain them a little bit better, let me give you some examples. My first example is the Cloud Storage Connector. A third party, a company called Cetera, developed a software application that backs up data from all devices in the branch office and then stores it in the cloud. It's kind of like a corporate version of Dropbox, but with remote archiving and backup, etc. Now, this is obviously very valuable as a standalone app. It secures corporate data and it reduces the need for local storage in the branch because it's archiving in the cloud. That's great. But by integrating with the Cisco network through a connector on the ISR-G2, they can now make it even better by using the intelligence of our network. For example, the network can advise the application when we're congested, so that they can now perform the remote backups only when the network is not busy with more business critical or real-time traffic. Another example of a connector is Xerox, who have Xerox have a cloud-based print service, so you can print documents from the cloud wherever you are, whatever device you're on. Again, it's a great application, but through connection on the ISR-G2, it can now use our network intelligence to be even better. For example, the router knows the location of the user and it knows the location of the printers. So the Xerox service can now access this location information from the network and can send the printout directly to the printer closest to the user without the user needing to do any printer setup on their device. When you think that by 2015, Gartner tell us we will have an average of 7 devices per person and that we'll be increasingly mobile, the ability to print wherever we are, whatever device we're on, without having to locate and set up printers on as many as 7 devices per person will be a great service. And what makes it great is the combination of the service from Xerox and the network intelligence from Cisco. So you can see how these third-party cloud services become even better when they integrate with Cisco and make use of the intelligence of our routers. And we've developed this as a framework, so you can expect that more and more of these third-party connectors will be developed over time. It's not only other companies, though, who can make use of these connectors. We've also developed our own. The HCS connector is one such example. Think about IP telephony. We've had something called the SRST for many years, which is functionality that in the event of a WAN failure, IP telephony in the branch and the PSTN breakout are still available. But some customers are now preferring to host their collaboration and call control in the cloud. We call that HCS. So if your call control is now in the cloud, how do we still guarantee telephony in the branch if the network connecting the branch to the cloud is disrupted? Well, the answer now is the HCS connector, which provides the same functionality as the SRST, but on the ISRG2. So when the WAN link is disrupted, the ISRG2 router sees that disruption, and with the HCS connector, it can provide backup call control so that branch telephony is maintained. Again, by connecting HCS with the network intelligence, we make HCS even better. A great example of an in-house Cisco connector is our ScanSafe connector. Here at Cisco, we've had ScanSafe functionality for some years. It provides web security, it protects devices against malware, it checks that URLs are safe, etc. And ScanSafe is already a service provided in the cloud. But the way networks are designed, 90% of traffic between the branch and the cloud is typically backhauled through head office. This increases latency and it costs money, but customers do it because it's at the head office where security measures, such as redirection through ScanSafe, gets applied. So we wanted to be able to provide that security from the branch router so that the traffic heading for the cloud doesn't have to traverse the head office. And we've done that with the ScanSafe connector. By adding ScanSafe connector to the branch router, we avoid that need to backhaul traffic through head office because we route all traffic from the branch into ScanSafe, which then assures the web security. It has another advantage as well, because currently ScanSafe is enabled via some configuration on each device. And because IT can no longer control every device that gets brought into the branch, thanks to consumer devices, there will be users who bring their own device into work and are thus not protected by ScanSafe. With the ScanSafe connector on the ISRG2, all traffic goes from the branch, regardless of the device, and therefore goes through ScanSafe service and guarantees web security. One last example I give you of a Cisco Cloud connector on the ISRG2 is the WebEx connector. Currently, you set up a WebEx, you trigger an audio call on WebEx, and that audio call traverses the telephony network at a cost, a per minute rate usually. But the network knows when it has enough free bandwidth to route that call across the network instead. So why not make use of that intelligence? With the WebEx audio connector on the ISRG2, the router can now decide to instead route those calls over IP for free. And the ISRG2 has the intelligence to know to only do this when the bandwidth permits and when other business critical traffic won't be affected. So that explains how connectors connect cloud-based services to the ISRG2 router so as to use the network information to deliver an even better service to the end user. Now let me talk about some of the other enhancements we've launched as part of the Cisco Cloud Connected solution. One major new product development is the CSR. So let me explain the CSR. Let's say I'm in the branch and I want to access some software as a service that's delivered in the cloud, maybe Salesforce.com or an Amazon service, for example. That traffic usually leaves the branch, goes into head office, goes into a data center, and then gets routed to the software as a service provider. But instead of all that looping, here at Cisco, we developed a way of providing connectivity directly from me in the branch to the software as a service provider in the cloud, cutting out all that other looping, that other usage of bandwidth. And we've done this with the CSR. The CSR is a virtual router that sits in the cloud. It runs as a virtual server on a Cisco UCS. So clearly you can see we've been able to bring this to market exactly because we have the UCS server capabilities and routing capabilities within our organisation. But it means that we can put the router functionality on that virtualized server in a virtualized environment, i.e. at the very heart of where cloud-based services are provided. So we can connect straight to those services from the branch rather than all this backhauling of traffic. This is new. And it has all of the routing and security functions of the ASR1K, which would normally sit in that data center environment. So it's a virtual router. Again, it's a virtual router that sits in the cloud and means we can connect to cloud services directly from the branch without all that backhauling and tromboning of traffic. Now, it wouldn't be a Cisco launch if we didn't make something faster. And sure enough, as part of the cloud-connected solution, we've dramatically improved the performance of the ASR 1002 router with the launch of the ASR 1002X. Now, this router is relevant to the cloud, particularly because the ASR 1K can be deployed in a number of places in the network, and two of those places are in the high-end branch and in the data center, i.e. the 2 points of connectivity between the branch and the cloud. So how have we improved it? Well, the ASR 1002X is almost 4 times faster than its predecessor, with a maximum speed of 36 gig. But moreover, what's really special about the ASR 1002X improvement is that a customer can purchase it now at the performance they require now, for example, maybe only 5 gig, and then as they adopt more and more cloud services, and so their cloud traffic increases over time, they can then increase the performance on the demand, say to 10 gig or 20 gig or 36 gig, but they can do it with just a CLI command on the router without any new hardware being required. The change is entirely software, it's based on an honours-based right-to-use license, and again requires no hardware change. So by deploying the ASR 1002X, the customer is buying a cloud-ready network that can later cope with additional bandwidth requirements as their cloud adoption grows. Other platforms do allow the increase in bandwidth, but they need a hardware change, a new network module. What's great about this platform is you need no hardware, it's entirely software. The security capabilities of the ASR 1002X have also been improved. We can now handle more than double the throughput of encrypted packets at a speed of 4 gig. The previous maximum was 1.8 gig. We've also delivered a performance improvement on the ISR G2 branch router because we've launched a full-scale UCS virtualization server that sits on the ISR G2. The G2 has had the option of a UCS Express blade actually for some time. It's kind of like a mini UCS. So customers who move to a virtualized data center environment still tend to have some applications which they don't consolidate into the data center and they instead retain them in the branch. Some may be Microsoft applications, file and print services, etc. The UCS Express has given those customers an option to still virtualize those applications in the branch with this blade in the router. Now we've enhanced that and made it even better by giving them a full UCS, not just a UCS Express, as an option in the ISR G2 so that customers can really virtualize applications that still remain in the branch as well as the ones that they move into the data center. Now finally, we also have some network services developments. Network services which are embedded in the Cisco IOS in the ISR G2. And the first one I'd like to call out is AVC, Application Visibility Control. AVC is really relevant to a cloud migration because it allows us to see into the packets of data that we are routing across the network and recognize which applications are being sent across the network. Now, why is that important? Well, for starters, it gives IT some visibility of which cloud services are being accessed by employees. Remember, IT no longer have control of all the devices, so they can't know from the devices what's being accessed. But now they can know it from the network. And then because we know which applications are being passed across the network, we can set policies accordingly and the network can effect them. For example, with WAS, we can optimize those applications. With QoS, we can prioritize some applications over others. And based on security policy, we can block access to applications which are not permitted, regardless of which device they're being accessed from. So if an IT organization, for example, decided it didn't want its users to use something like Dropbox as an example, it can block that in the network, even though it can't block it on the device which it doesn't control. It even allows IT to block access to some applications for some employees or job roles, but allow it for other job roles, for example. So AVC really enables IT to know what cloud services are being used, what their performance is, and without AVC, it's all just cloud traffic. So IT may no longer have full control of the device, but they do have full control of the network. And this allows them to use all that network control to secure the environment again and to guarantee a level of service for users. And AVC is a really big part of that. Another network service that we offer is FlexVPN. When accessing the corporate network, including when we're accessing the public and the private cloud, VPN is traditionally used, but the VPN method can be different dependent upon access means, configuration, etc. So sometimes it will be DMVPN, other times EasyVPN, sometimes CryptoMac. Now, as part of the Cisco Cloud Connected launch, there is just one mode of VPN, FlexVPN. So regardless of whether it's a hub and spoke deployment, remote access, point-to-point, the VPN access method will be VPN, which means VPN access is now considerably more operationally efficient for IT. I want to point out also that FlexVPN is based on VPN protocol IKE version 2, not IKE version 1. What do you need to know about that? Why is that relevant? Well, it's relevant because IKE version 2 is less chatty than IKE version 1. In other words, it takes less messages to set up a VPN connection. IKE version 1 uses 6 or more messages to set up a connection. IKE version 2 uses only 4 messages. That doesn't sound like a lot of difference, 4 messages instead of 6, but when you consider that thousands of VPN connections are set up every day, and when you then also consider we're moving to an environment where people are increasingly mobile, constantly changing location, constantly having to re-establish that VPN connection, you can see that actually it does make a big difference. When you then also add to that by 2015, there will apparently be 7 billion interconnected devices in the world. That means that that's a lot of VPN connections that are being set up every day. So being based on the less chatty IKE version 2 is a really big advantage of FlexVPN. So let me summarize. The only thing connecting users and devices in the branch to the services and applications in the cloud is the network. Here at Cisco, we wanted to find a way of using the intelligence in the network to give our customers the best cloud experience possible. So we developed the features that I have described here today. To gain access to these features, positioning the ISR G2 in the branch is an essential step, migrating from the ISR G1 perhaps if necessary, because what I hope I've demonstrated is that a critical stage of successfully migrating to a cloud environment is migrating to a cloud-ready WAN. That cloud-ready WAN is brought to you by all the things I've talked about today, which together we have called the Cisco Cloud Connected solution. Thank you.